Hey again, another quick intermission. You're past the halfway point, so congrats again. By now, I really hope you've already learned a ton from the course. We've already covered lots of topics and built a ton of systems. I hope you've been following the website as you go through the lectures, and I hope reading the frequently asked questions has helped you in some way. Let me know in the comments how you've used the course website. Did you just read the FAQ, or did you also download some project files? Let me know, I'm curious to know. If you enjoy my teaching style, also look at my other courses after finishing this one, especially the turn-based strategy course. That one is an excellent follow-up for this one. Okay, there's still quite a bit more for us to build and learn, so let's continue in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build the stove counter. So we want to place some uncooked meat, then we wait for a bit for it to be cooked. However, if we wait too much, it's going to get burned. So let's implement that. Alright, so as usual, let's first begin by making our counter. So let's go inside the prefabs, the counters, let's right click on the base counter and create a new prefab variant. Call this the stove counter. And as usual, let's go inside of it. Let's find the visual. So inside the prefab visuals, the counters visuals, here is the stove counter. So let's drag it. Then let's duplicate this, rename this one the selected. Let's set the component, the selected counter visual. Then let's go inside on all of these. And by the way, this visual actually has some nice visuals that we're going to implement in a little bit, but for the selected, we really just want the static objects. So let's pick up all of these and let's select the counter select visual. Okay, nice and white. Then let's lock over here the parents so I can select all of these and drag all of them. Okay, great. And start off with all of them disabled. Okay, so that's the basic setup as usual. Just for the counterpoint, since this one has a nice little sub on top, let's lift it up by a little bit. So put it on a Y of 1.456. Okay, that looks pretty good. Just move it a little bit to the center. Okay, great. So now let's make our script. So let's go inside our scripts folder. We've got our counters. So in here, let's create a brand new C# script for the stove counter. Let's wait for it to compile. Let's attach the script and open. Okay, so here as usual, let's extend the base counter. Now, like I said, the goal for this one is to be able to cook our meat. And for that, it's going to be based on a timer. And to actually cook the meat, we're going to need to know which one is the uncooked meat type and which one is the cooked meat type. So for that, we really want the exact same logic that we did for the cutting action. We want some kind of place where we can store an input and output as well as a cook timer. So for that, let's actually just duplicate. So let's go inside our scriptable objects for the cutting recipe and let's duplicate this one. So Control D. And let's name this one the frying recipe SO. Okay, let's go inside. And over here, let's rename the object. Then we have an input, we have an output. And then instead of progress, let's have the frying timer max. And since this one is a timer instead of an int, let's make it a float. Okay, so that's it, pretty simple. Then back here in the editor, let's create our scriptable object. So let's go inside, let's make a nice folder. So a folder for the frying recipe SO. And inside, let's create one. So let's create a brand new frying recipe SO. For this one, let's call it meat patty uncooked into meat patty cooked. Then for the inputs, let's choose the meat patty uncooked. Now we have to make the other one. So let's go ahead and make that one. Let's duplicate this one, rename it to the meat patty cooked. And the object name, meat patty cooked. Let's select the different sprite. So this one is going to be the meat patty cooked, okay? And finally for the prefab, let's also make it. So for the meat patty cooked, let's go inside of it and also make sure to save the changes on our stove counter. So okay, now in here, let's get rid of this visual and use the other visual. So we want the meat patty cooked and let's make sure to drag the scriptable object. Okay, so it's all good here. Let's go back outside, save it. And finally over here on the meat patty cooked, let's just grab the prefab reference. So there you go, that one. Okay, so this one is working, and since we're here, let's actually make the other one right away. So let's make the meat patty burned. So the prefab, and let's also duplicate this to make the meat patty burned. Then on the text, let's rename this to burned. Let's choose the burned icon. And for the prefab, let's go into our meat patty burned and swap it out for the burned one. So there you go, nice and charred. And over here, swap it for the meat patty burned. Okay, let's save it. And finally down here, just make sure everything is correct. So the meat patty burned, just drag the scriptable object, the transform prefab, just like that. Okay, so all of our burned references, over here all of our cooked, and over here all of our uncooked. And again, when going through this process, always make sure that you match all the references on the scriptable objects, and also over here on the kitchen objects. So meat patty burn, yep, meat patty burn. For the uncooked, and for the cooked, there it is. Okay, everything is good, great. So now we can go back over here into our frying recipe SO, and for the output, let's output the meat patty cooked. And for the frying timer, let's put it on 3 seconds. Okay, so that's it, great. Now back in the code here on the stove counter, let's add an array of our frying recipes. So a serialized field, private, it's going to be an array of frying recipe SO, so frying recipe SO array, and call it frying recipe SO array. Okay, great. Then back here in the editor, let's go inside the stove counter. Let's make sure to drag that. So let's drag the meat patty from uncooked into cooked. Okay, let's also drag the counter top point. And finally, since we already made the script over here on the selected, we can also drag the selected. Okay, so our stove prefab should be working. Okay, let's go outside, make sure to save the prefab. Okay, now let's continue with the rest of the script. So let's make our override. So override the interact action. And when we interact with it, let's validate dropping the object just like we did on the cutting counter. So let's go over here into our cutting counter script and let's just copy pretty much the exact same thing. So let's copy all of this interact code. Let's go over here in the stove counter and just paste it. Now we also need to copy in our recipe. So over here on the cutting counter, let's copy paste those functions. So these functions go into the stove counter and over here let's paste them. They're going to work pretty much the same thing. So we get an input, except instead of being a cutting recipe SO, we're going to have a frying recipe SO. So let's replace all the cutting recipe references with frying recipe reference. Then for the array, this one is the frying recipe SO array, and obviously let's rename these. So Control RR to rename all of them into frying recipe SO. Let's also rename the function. Instead of get cutting recipe SO, it's the frying recipe SO. Okay, so there's no more mentions of cutting over here. So let's use this function up here and up here. And just make sure to rename these the frying recipe SO. And down here, also same thing, so the frying recipe SO. Okay, so down here we have no more mentions of any cutting. Let's just go up here and solve all of these problems. So first we check if there's no kitchen object here, and if the player is carrying something, then we see if what the player is carrying matches any kind of frying recipe. If so, then the player is carrying something that can be fried. Then we set the parent, and for now let's not worry about the progress. So let's just get rid of all of this, just like this. Okay, so with this we should be able to drop, but only an uncooked meat. So back in the editor, let's just set up our scene. So let's drag a stove counter onto our scene. Let's put over there on X of 6, Y of 0, and 3.5. Alright, so let's test. Okay, so now if I pick up some cheese, I go up there and I drop it, and nope, doesn't work. Okay, great. But if I pick up some uncooked meat and I go and I drop it, and yep, that does work. Okay, great. So it works and I can only drop the actual objects that match the recipe. Now, unlike the cutting counter, this one will not be based on a player-alt interaction. And actually over here, let's fix this minor issue. Basically, we added this debug.log error to the base interact because pretty much every single counter is going to implement this interact function, but not all counters are going to have the interact alternate action. So on this one, let's just do nothing. Let's not spawn an error. Okay, just a quick fix. So like I said, the stove counter, this one is going to be based on a simple timer. And for making some time-based logic, basically we have two approaches. One approach is to use a simple float timer, or you can also use a coroutine. Now, a lot of tutorials will teach you how to use a coroutine, and that's not necessarily a bad practice. It does work. It does achieve the desired result. So to do that, you would just make a function like fry timer. So you'd make a private, you have to return I in numerator, then call it something like handle fry timer. Then inside you can do a yield return and return a new wait 4 seconds. And to start this coroutine, you would do maybe on start, you would call start coroutine and start the handle fry timer. So this is one approach. This is definitely perfectly valid timer code. However, personally, I am not a fan of coroutines. It's not because of performance or anything. It's simply because I don't like the pattern that they force you to use. I don't like being forced to make a function that returns I in numerator. I don't like using yield return. I don't like having to use the start coroutine function. I don't like being forced to use this on a monobehavior object. Those are all requirements for making a coroutine work. And personally, I find those are way too many requirements that create a very strange pattern that I really don't like. So that's really the only reason. I don't like coroutines because I find this pattern to be quite a lot convoluted. So instead of coroutines, what I like to use are simple basic flow timers. So just make a simple private void update. Then we just need to keep track of a certain timer. So for example, a simple private float frying timer. Then on the update, let's first check that we have an object, so it has a kitchen object. If we have a kitchen object, then let's increase the timer by time.time. By the way, here when working with a timer, you can increase or decrease. It's pretty arbitrary, both ways work. The obvious difference is only if you test if it's above the max or if it's under 0. In here for frying, it does make sense to start at 0 and then the frying timer max. So you do that, and if the frying timer, if it is bigger than the maximum, so let's get the frying recipe SO, let's get the frying recipe SO with input, so let's get this kitchen object and get the kitchen object SO. Okay, so we go into the frying recipe SO and we get the frying timer max. Okay, so if it's above the max, then this one has been fried. So here let's just see what we did on the cutting counter. So let's get this kitchen object and tell it to destroy itself. And then let's go into the kitchen object class. In order to spawn another kitchen object, let's go into the frying recipe and spawn the output. And we're going to spawn it inside of this counter. Alright, so that's it. This should already be working. We don't have a visual yet, so let's add a debug log. So up here, just a debug.log on the frying timer. And up here, let's also just reset the timer. So frying timer, let's put it on 0f. And let's also do a debug.log and say fried. However, like this, you might already be guessing that we're going to have a bunch of bugs, but still, let's just test it just like this. Okay, so over here I can move around, I can pick up some uncooked meat, I can drop it there, and after a little bit, there you go, there's the timers. And yep, there you go, it did work. You can see the timer increased until 3, then it was fried, then it was reset, and then we've got a null reference exception. Basically, this is the exact same problem that we had on the cutting counter, where first we put an object like tomato, and that is indeed an input for a recipe. So we cut tomato into slices, but then the slices are not an input for any recipe. So over here we put some uncooked meat, so that's great, we fry it, which means we destroy the uncooked meat and we spawn the cooked meat. But then next time the cooked meat is not an input for anything, so obviously this one is going to return null. One thing we can do to sort of solve this problem, which is also going to be beneficial in terms of performance, is simply caching this field. So let's go up here, define a frying recipe SO. Instead of constantly getting it on every single update, which might be a bit costly in terms of performance, instead of this, let's just get it over here when the player drops something. So the player drops something and we assign the frying recipe SO, so we assign it, cache the value, and then do this. Okay, that should have fixed the null reference problem, but we still have a bunch more problems, but still, let's test it out. Okay, so here, let's pick up some meat, put it there, and let's look at the timer, and yep, there you go, everything is cooking, great, and yep, there you go, it finished, it cooked, and the timer was reset, and now it's finishing, it's cooking, and so on. So this is obviously another pretty serious problem. Basically, it's constantly frying the meat and spawning more and more objects. Instead of constantly spawning from the same recipe, what we want is for the stove to first fry the object, but then if the object is fried, then we want to burn it. So really, that means that we want the stove to have multiple states. Meaning that we're going to need to make a simple state machine. So let's do just that. Now, if you're a beginner, the concept of a state machine might seem daunting at first, but it's actually extremely simple, at least to make a very basic one. All we need is really just a bunch of states. So to define those states, let's go up here and make a simple enum. So let's make a private enum, call it state. And now let's put all the states for our state machine. Now for the stove, let's say we have idle when there's nothing on top. Then let's say we have a frying state for when the ingredient is actually being fried. Then we have fried for when the ingredient has already been cooked, but it's still getting some heat. And finally, if we leave it too long in that state, then everything ends up burned. Okay, so these are all of our states for our state machine. And now to make the actual state machine, it's actually quite simple. First of all, we just need to store the current state. So up here, make a private of type state and store the current state. And then on update, let's just do a switch on the current state. And now here, basically, we're going to do different logic depending on the state that we're at. So let's say if we're idle, we do something. Then if we are frying, we're going to do something else. Then if we are on the fried, also something else. And finally, if we are on burn, do something else. So here are all of our states. And the logic that we did down here, this is the frying logic. So let's actually just copy all of this. And let's paste it inside the frying logic. And for the state machine, we're only going to run any of these states if there's a kitchen object inside of it. So let's actually put that switch in there just like this. Okay, so that's it. So when idle, we're not doing anything, and when frying, we're going to run our frying timer. We're going to fry the object. Let's also get rid of the log, we no longer need this. Then we destroy the current object and we spawn a brand new object. Now what we need is to handle over here the state field. We need to modify this when changing states. So first of all, let's handle the start. So let's make a private void start. And on start, let's begin with the state on state.idle. Okay, great. Then down here, when we interact, when the player drops something, that can be fried, over here, let's set the state and put it on state.frying. And over here, we should also probably reset the timer. So let's set the frying timer back into 0F. Okay, we set the timer and we reset the state. Finally, up here, let's not reset the timer since we're resetting the timer down there, since it makes more sense down there. So we do the frying timer, we end up frying, and then obviously we need to modify the state. So modify state and put it on state.fried. Okay, so that's the basics of our state machine. With this, everything should be working just the same as previously, except we're only going to fry once. So let's actually just put a log here, debug.log, object fried. And let's put one down here outside of the state machine. Just do a debug.log on the state. Okay, like this, let's test. Okay, so here we are. Let's pick up some meat and drop it on there. And there you go, it goes from idle directly into frying, and then it's fried. And yep, there you go, now it stays on fried. So it no longer goes on frying and it's no longer spawning any more objects. It went from frying into fried and yep, everything worked. All right, awesome. So we have the frying state working perfectly. Now let's handle the burning. In terms of logic, it's really going to be the exact same thing. We're going to have a frying timer. So let's copy this code and paste it down here. Now, technically we could reuse the exact same float timer, but that would be a bit confusing. So let's keep our code as clear as possible and really just make a different timer with a more descriptive name. So up here, a private float, call it the burning timer. Then let's initialize this timer. So when we go into the fried state, let's set the burning timer into 0. Then down here, let's use this burning timer. Okay, great. When timer is elapsed and the object is spawned, let's go into the burn state. And now obviously we need another recipe. So let's make another scriptable object. Back in the editor, let's find the frying recipe SO. Let's duplicate this. Call it the burning recipe SO. Then over here, let's modify the name. Instead of frying timer max, let's call it burning timer max. Okay, great. So now over here on the stove, let's use pretty much the exact same thing. And let's make over here private of burning recipe SO, the burning recipe SO. Then down here, we just need a function to get the burning recipe SO. So let's copy this and paste it over here. This one's going to return a burning recipe SO. So let's replace this and this. Rename this into burning recipe SO. We're going to need an array, and over here, let's just change the name. Instead of frying recipe SO, the burning recipe SO. And finally, let's just find a new array. So let's go all the way up here, make another array, an array of burning recipe SO. And this is the burning recipe SO array. And finally, if we go down here, let's use this array. Okay, that's it. So now let's use this function to set our burning recipe SO. So when we set it to fried, let's set the burning recipe SO. And let's get it with the input, and the input is going to be the object that is on here. So the kitchen object dot get the kitchen object SO. Okay, so we're initializing our fried state and setting up the burning recipe SO. And over here we use that one dot max, and we go into that one and use the output. So over there object fried, and over here object burned. All right, so that's pretty much it. We modified everything to say burning timer. Over here we are correctly initializing, so we go through the burning timer, through the burning recipe SO, which we are grabbing up here. Then we spawn the output on the burning recipe SO, and we go into state.burned. Okay, so all that's left is just filling in this array. So back in the editor, over here, let's make the object. So let's make a brand new folder for the burning recipe SO. And now inside, let's create a new burning recipe SO. Call this one the meat patty cooked into meat patty burned. And over here, let's set the input, so the meat patty cooked onto the meat patty burned. And for timer, let's make it take a bit longer to burn, so let's say 5 seconds. Okay, that's great. Let's just drag the reference, so let's go into the stove counter, and let's make sure to open up and go inside the prefab. And over here on the prefab, just drag the burning recipe. Okay, that's great. Let's go outside, save the prefab, and let's test. All right, so here we are. Let's pick up some meat, drop it on there, and look over there, it's frying, and after a bit, Yep, it's fried. There you go. It spawned that one. And now if we wait for 5 seconds, it should go from frying into burn. And yep, there you go. That one is charred. Everything is burned. Everything is great. All right, awesome. So everything worked as intended. With this, all of our logic is working. Now let's handle picking up objects from the stove. Now technically it's already working, so I can approach the stove and pick it up the object. And there you go, drop it in there. So that does work. However, if we look over here in the log, the state machine is now in the wrong state. So over here, let's do a quick fix. Let's go down into the interact action. Okay, so here it is. So if there's no kitchen object, then the player places it. Okay, that's good. But if there is a kitchen object, so if there's something on the stove counter, when the player picks it up, let's also manually set the state and put the state back into idle. Just like this. Okay, that's it. So let's test. Okay, so over here, let's pick up some meat, put it in there. It's cooking, and let's wait until it gets finished. Yep, there you go. It's done. Pick it up, and there you go, out. Now, if I want, I can put another one, and yep, there you go. The logic is reset, and everything is back to normal. Okay, great. So all of the logic is working perfectly. Now, let's just get rid of our logs, so we don't need this. So let's get rid of that debug log, this one, and this one. Okay, great. Everything is nice and clean. And now let's add some nice fun visuals. So if we go inside the stove counter, and over here is the visual, and I include these two prefabs inside the visual. So one of them, this one, the stove on visual, this one is just a glowing red square. Now again, there's a weird bug on this specific Unity version, so post-processing isn't showing over here on the scene view. But if I leave it enabled and I go back outside, and now if we look in the game view, yep, there you go, there's a nice glowing red square. If you don't see it glowing, make sure you add the bloom post-processing effect. So if you missed something, you can go back into the post-processing lecture and make sure everything is set up correctly. So there's a nice glowing red square, and there's also a bunch of particles. So you can enable this one, press on restart, and there you go, just some nice particles just jumping up. This was made with the Unity particle system. So for example, on the hierarchy, you can right click, go up here into effects, and you can create a particle system. So that's what this is. It has a particle system. And over here, you can see all of the various settings. For these particles, they just jump up and fall down. So for jumping up, that is the emission. You can actually see a visual over there of the cone. That is the spawning cone, which you can find over here on the shape. So in the shape, it has the shape of a cone. Then you can see the radius thickness, and so on. So that is from where the objects are being spawned. Then up here, you can see the lifetime of each object. So each particle is going to last for 0.7 seconds. You can also see the speed. So that's the speed at which they come from there. The start size, that's how big they are on start. And note how the particles are spawning, jumping up, and falling down. So that falling down is over here the gravity modifier. If you put it at 0, then they just keep going up. And if you put it at 2, yep, they go up and they fall down. Next down here on the emission, this is how many are being spawned. So if I put this on 200, there you go, tons and tons of particles. Next is over here the size over lifetime. So this one has just a basic curve. So they start off on full size, and over the x-axis, this one is the lifetime. So as the particle goes from the beginning until the end of their life, they basically go down on size, so that is why they become quite a bit smaller. Also, by the way, this one down here, this one is called an animation curve. This is another really useful Unity feature. I have a dedicated video on animation curves. And finally, down here, just have the renderer. So it's just using some basic particles, so we can inspect the material, it's included in the assets. And there you go, it's just using the default particle material, just with the alpha on half, and that's pretty much it. So as you can see, just a very basic, very simple particle system. Now all we really want to do is just, for both of these, we want to enable or disable them depending on if the stove is on or not. So let's make a script to handle the visuals. So let's go down and create a brand new C# script. Let's call it the stove counter visual. Then let's go into the stove counter visual and let's attach the script. So here it is, attach it and open. Right, so now here we just need references to those two objects. So as usual, let's make a basic serialized field. Let's make it of type game object. For the stove on game object, and the other one is the particles game object. Okay, let's save. And back here in the editor, let's drag the references. So the stove on visual and the sizzling particles. Okay, great. So now all we really need to know is when to turn these on or off. And for that is really going to be based on the state over here on the stove counter. So if it is on the state frying or fried, then we want to show them. If it is on idle or burned, we want to hide them. But as usual, we don't want to mix the logic and the visuals directly. So let's do that through a really nice event. Let's make a public event. Let's use a standard event handler. Let's call it on state changed. And let's also include the state on the event arc. So let's make a public class. Call it on state changed event args, and let's expand event args. And then in here, let's just put a public state for our state. However, here we also have a really nice error. So this one is telling you there's inconsistent accessibility. Basically, that's because we made this one public. So any class, like for example our visual class, can indeed see this class. However, from outside, that class cannot see the private state. So that is why we have inconsistent accessibility. We cannot have something public which inside has something of a specific type which is private. So in order to make this work, we need to modify this state and make it public so that the other classes can see it. Okay, so that's great. Now let's just fire this event whenever the state changes. So over here, when you go into the frying state, let's go and invoke, and as usual, just this. And I actually forgot to add that, so let's go up here. Let's use the one with generic, so the on state changed event args. Okay, great. So then down here, when invoke the event, let's create of this type. And inside passing the state equals this state. Okay, so this is all we need. So then down here, going to the burn state, let's fire the event. And down here, frying, fire the event, and on idle, fry the event. All right, that's it. So we have all of our state logic. And now over here on the stove counter visual, obviously we need a reference to the counter, so let's add that. So a serialized field, private, make it of type stove counter for the stove counter. And then we can do, and as usual, for accessing external references, let's do it on start. Go into the stove counter, and let's listen to the on state changed event. And over here, it's going to be very simple. We just want to show if it's on the state frying or fried, and if not, we don't want to show. So let's define a bool, call it show visual. And this one is going to true if the e.state equals the state.frying, or e.state equals the state.fried. So if it's either of these, then this is going to be true. If not, it's going to be false. So then let's just go into the stove on game object and call setActive and pass in this. And same thing for the other, for the particles game object. Okay, that's it. Super simple. Let's just drag this reference. So over here inside the prefab, just drag the reference. Let's leave the prefab, save the changes, and let's hit on play. And all right, so it starts off disable. Okay, so there's no visual. Now if I pick up and I drop it, and there you go, a nice visual. So the glowing red hot and the particles, and now it's frying. And if I leave it until it burns, when it burns, then it's going to turn it off. And if there you go, it turns off. All right, awesome. So now if I pick it up, wait until it gets cooked. So it's cooked, pick it up, and there you go, turns it off. All right, awesome. We've got a really nice visual. All that's left is to have a proper visual progress bar. And with this, we actually have another interesting clean code question. Right now, the progress bar that we made over here on the cutting counter, that one is great, so we would like to reuse that. However, if we look over here on the progress bar UI, we can see this is only working with the specific type cutting counter. So by default, this will not work with a stove counter. So as usual, we have multiple approaches to solving this problem. One option would be to simply completely duplicate the script. Then we would make a completely different progress bar UI class that would work only with the stove counter. So that's one approach that would work. And that approach might be good if you want the progress bar to behave very, very differently. But over here, I want both of them to behave exactly the same. So instead of having some code duplication, we can write some good clean code, but doing exactly what we did with regards to the kitchen object parent. Meaning we can use a nice interface we can then implement on anything that has some kind of progress. So let's do exactly that. First of all, let's actually go inside the cutting counter. So let's go inside the prefab. And over here, we've got the progress bar. And this one is just a regular game object. But since we're going to reuse this, let's make this a proper prefab. So let's find over here all of our prefabs and just drag the progress bar UI inside the prefabs folder. Okay, great. So this is now a proper prefab. Now let's define our interface. So let's create a brand new C# script. As usual, interface starts with I. So let's call it I. And for this one, we wanted to represent anything that has progress. So let's just call it literally has progress. Personally, I like to use the word has to indicate that a certain object has certain behavior. So in this case, objects that implement this interface will have some kind of progress behavior. So now over here for the interface, let's first make it so this one does not extend modified behavior. Instead of a class, this one is an interface. Okay, great. So now for the functions that we're going to need, if we look in the progress bar and we look at the cutting counter references, we can see the only one is literally just this. So we just have to listen to the event, and then the rest of the progress bar works inside of it. So realign the interface is the only thing we need to define. So let's actually go inside the cutting counter. So here we have the onProgressChange event, and then we have this, so we can literally just copy this, go into the I has progress, and let's put exactly this. Okay, that's it. That is literally all we need. Now, if we wanted, we could also make a function to expose the progress amount, but since we included it over here on the event, then we really don't need it. Just this is enough. Now let's go over here on the progress bar UI script. And instead of working with the type cutting counter, instead let's work with a type that has I has progress. So let's rename this to has progress. And it's going to have the exact same event. The only difference is over here, instead of the event args being the one inside the cutting counter, is the one inside the I has progress. So let's make sure to change this, I has progress. Okay, so the signature matches. Let's just obviously rename this. So let's rename, instead of cutting counter, let's rename has progress on progress changed. And that's pretty much it. We don't have any more errors, so everything over here is now working nicely with our interface. And back here in the editor, whilst we're still inside the cutting counter, sadly, interfaces do have one downside when it comes to Unity. If we look in the progress bar UI, down there we can see the progress bar UI, and previously we had the counter field exposed in the editor. However, now by changing into an interface, there we have the issue. The field does not show up here. Interfaces do not show up in the editor because Unity basically has no way of knowing that the interface will be implemented by some kind of game object. So sadly, this is the one thing that doesn't work very well with Unity. The solution that I normally do is actually pretty simple. Instead of exposing the interface, which does not work, instead let's just make this a regular private field. And then let's make a serialized field, and for this one let's make it of type game object, and let's call it has progress game object. Okay, so like this, we have a regular serialized field with a regular game object. So if you look here, yep, we do have that field. So now we can indeed drag the cutting counter reference. And then over here in the code, in order to get the has progress, that is super simple. Has progress, we just go into the has progress game object and get component of type I has progress. Okay, so that's it. Now our code does work. However, of course, one big potential issue with this is that over here we have a field of type game object, meaning that we have no guarantee that this field does have a component that implements the interface. So we cannot make sure that we drag the correct reference. We can drag any reference, doesn't have to have our progress interface. So in order to keep ourselves safe, let's add a nice safety warning. So over here, if has progress equals null. So if this one is null, that means that that game object does not have any progress interface. If so, let's do a debug.log error. And let's say the game object, and let's pass in this game object, does not have a component that implements I has progress. So this way, if we make a mistake, we will have a nice error message. Basically, this is the one workaround that you need to use since Unity does not support dragging references in the editor if they are interface references. Okay, so with that, everything is good. So all of our progress bar UI, this should all be working perfectly. We just need to go over here into our cutting counter script, and let's make it so that we implement our interface, so I has progress. And we got an error just because even though we did define that interface member, the onProgress change, again, keep in mind that the types depend on not just their name, but where they're at. So this type that we have here is the one that we define here, which is not the same one that we have here. So even though they have the exact same name, because they are in different places, they are actually different types. So we need to make sure to use the type in the interface. So over here, let's just go into the I has progress and use that exact type and get rid of this one. Okay, so that's it. That's the change we need. And down here when firing, let's just fire with that type, and down here the same thing with that type. Okay, great. So like this, the cutting counter should still be working exactly the same as previously. Again, when refactoring any code, always do a quick test. So let's do that. Let's make sure to save our counter, save the prefab, go back outside, hit on play. Now let's pick up some cheese, put it there, cut, and there you go, the progress bar still does work. Okay, great. Now let's apply it to the stove, and that is actually going to be very simple. First, let's go inside the stove, so let's find the stove counter, let's open it up, go inside the prefab, and over here let's drag the progress bar UI prefab, so let's drag that. Then down here we already have the has progress game object, so let's drag the stove counter, and that's it. There's nothing else we need to touch here. We just need to go over here into the stove counter, and as usual, let's implement the interface. So the I has progress. And now let's implement it pretty much just like we did on the cutting counter. So we can actually just copy this. So we just need to implement the event. So that's it. And now for firing the event, let's go down and see where we are modifying all of our timers. So let's go down to when the player drops something. So we do the onState change, and now let's invoke this event. So this, and for the progress bar, for the progress normalize, this one's very simple. So just frying timer divided by the frying recipe SO dot frying timer max. Okay, that's it. We are modifying the progress. Now let's go up here when we are in the frying state. And when we do, let's fire off the on progress change event. Okay, great. And finally down here when we have the frying, over here let's also fire, except obviously we have the burning timer and the burning timer max. And then just to make sure that the bar actually hides itself when we go into burned, let's also fire an event. This one doesn't have a timer, so let's just put it on 0F. Okay, that's really it. We don't need to touch the progress bar UI at all. Let's test this. Just make sure to save the prefab. Let's go back outside and hit on play. And right away, yep, the bar is indeed hidden. Now if I pick up some meat and I drop it, and there you go, got a really nice bar going up. And yep, going up on the burning state. And as it gets to the end, let's see if the bar hides. So it gets to the end. And yep, there you go, the bar does hide. All right, awesome. And if I pick up something, actually this was the one event that we forgot, so let's fix that. So let's just copy the one where we set the progress normalized to 0. And over here, if the player picks up something, let's set the progress back into 0. So here we are. Let's pick up some meat, drop it on there. Okay, let's wait for it to be cooked. Okay, it's cooked. Now before it burns, pick it up, and there you go, the bar is gone. All right, awesome. Okay, so here we have, again, another example of the power of writing good, clean code. We made a nice generic progress bar, and we very easily made it work with a completely different counter. Which of course would also work with literally anything that implements that interface. It doesn't have to be a counter. Now let me make one note here. Basically I showed you how to make a generic progress bar and reuse it. But let's say you want to do something specific just for the stove. Well, one approach, like I mentioned, is to duplicate the code and make a progress bar that works only with the stove. But another approach is to simply add more elements on top. For example, during the polish stage, we're going to do exactly that. We're going to add an extra UI element that will show up to warn the player when the food is about to burn. So I just wanted to point that out, how you can mix and match both of them. You can have both generic components coupled with specific components. But for now, our progress bar, everything is looking pretty good. So let's leave that burn warning just for the polish stage. Now the next very important thing we need is some plates, so let's do that in the next lecture.